welcome everybody to the homework helper for section number 9.8. We're going to start by describing spread. And so the first thing that it's looking for here is it's asking us to find the median, the range, and the interquartile range. And the interquartile range is just a fancy way of saying where the first quartile starts, the second quartile starts, and the third quartile starts. It's just a fancy way of saying that. So we can go ahead and do this no problem. When we look at this, we can tell immediately that our median is that number in the middle. So we know that the median is going to be 5.5. We know that the range is how far it is from our lowest number to our highest number. Our lowest number is 3 and our highest number is 9. So we know that the range is going to be 6 because it takes 6 steps to go from 3 to 9. And then the interquartile range, well, we see that look at our numbers here. We know that this is 3, we know that this is 4.5, we know this is 5.5, we know that this is 7. And that's it. That's all that it's asking you to do, is to make sure that you understand what those are. And then it's going to ask you some further questions, but as long as you understand what the median range and interquartile range are, you should be okay to be able to answer those questions. All right, let's go ahead and move on to some of the new stuff. For this one, it's asking us to talk about residual plots and correlation coefficients. So the data sheet for exercise 5 is a scatter plot, like so. And so what we have to do is we have to figure out what our x bar, y bar is. And to do that, we need to take the average of all of our points here. So we're going to start that by figuring out what our x bar, y bar is. So the first thing I have to do is figure out the points of all of these. So I can do that pretty simply. Let's see, this is 5, so this is 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16. So I know the x values of all these points. This is 1, wait, no, I'm sorry. This is 2 something. This is 4 something. This is 5 something. This is 7 something. This is 9 something. This is 12 something. This is 16 something, okay? So now I just need to figure out my y values of each of these. Okay, this is 30. This is 25, 26, 27, 27. Okay, this is 25. This is 15, 16, 17. This is 15. This is 6. And this is, that appears to be 1. So now I have all of these values, and so I can find my x bar, y bar by calculating the averages of my x's and my y's. So I'm going to do just that with my calculator. So I'm going to start with my x bar. So I'm going to do 2 plus 4 plus 5 plus 7 plus 9 plus 12 plus 16. Oops, okay, hit enter. So that's 55, and I have 1, 2, 3, 4, 5, 6, 7 points. So I'll divide that by 7, and I see that my x value of x bar, y bar is 7 point, I'm going to round it to 86. Okay. Now I do the same thing for my y values. I'll go the same way. So I do 27 plus 30 plus 25 plus 17. Whoops, I said I didn't plus. User error, let's fix that. 27 plus 30 plus 25 plus 17 plus 15 plus 6 plus 1. Divide all that by 7. You get 17.29. Okay, and so now I need to mark where x bar, y bar is. And so that's going to be at the point 7.8, so pretty close to 8, and 17.2, so pretty close to 17. So it's like right here, right there. That's my x bar, y bar. Okay, and so I've marked it on my graph. Now I'm going to do the residual plot. I'm going to see how far away each of these is. So we're going to use the given data sheet, and we're going to try to figure out how far it is. This is going to be a bit of a challenge because it doesn't fit exactly, but we're going to do the best we can visually. I mean, typically we'd like to have the equation, and maybe we So if I can figure out the slope, I can figure out everything else. Oh yeah. Let's see. So it appears to cross perfectly here. Doesn't really cross perfectly for a while. Right here. Yikes, yeah, that's a crazy far slope. Yeah, so we'll just eyeball this one. We could do it, but it is a bit of a challenge. Maybe it's not that bad. Maybe we can actually do this because it goes 30 to 2, so it's a change of 28. Right, our slope is our change in y, and our change in x is 28 over, and we go from 2 to 15, which is 13. Oh yeah, that's a super ugly number. Oh my gosh, that number's hideous. Okay. We know that it's a negative change. So we know that the equation is going to be something like y equals negative 28 13ths x plus some b. We don't know what the b is, but we can plug in this number, 15 2. Hey, I'm in the middle of recording something. So I can plug in the point 15 2. I can plug this into my equation here. So when I do that, I get 2 equals a negative 28 over 13 times 15 plus my b. Oh my gosh, it's going to be an ugly number. So this ends up being 28 divided by 13 times 15 equals all of that. Oh my gosh, 2 minus that answer. Oh my gosh. Okay, so here's what we're going to do. We're going to say, let's just eyeball this thing. So when we just eyeball it, we see at 2, we have about negative 1, 2, 3. So we'll just call that negative 1, 2, 3. The next one's at 4, that's a positive 1, 2, 3, 4-ish. So 4 is 1, 2, 3, 4. Here it's about a positive 1 and 5. So about right there. At 7, it's a negative, we'll say 1, 2, 2.5. It's a negative 1, 2.5. At 9, it's right on there, so we'll just leave a dot there. At 12, it's a negative 3. Just about right there. And at 16, it looks like it's a positive 1. 16, it's a positive 1, so it kind of looks like this. Okay, so that's our residual plot. So given this, let's try to figure out what our correlation coefficient is. So what we can see here is that we have 3 below, we have 3 above, and 1 on there. So it seems like that's going to be a pretty good line of best fit. And they're also pretty close, like they're all within 2 or 3 or 4. So if I were to estimate a correlation coefficient for this one, I would probably guess that our R would be pretty, it looks like a strong negative, right? Because it is a negative correlation, as one goes up, the other one goes down. It is a negative correlation, but it seems to be pretty strong. So I'd probably give this like a negative 0.8, because they're all fairly close to the line. But that's how we're going to do it. I give you guys permission to not use the equation and just eyeball it. Okay? Because that equation made me want to rip my eyes out. Okay. Here are some other ones that, in this case, it wants us to do some analysis. So let's go ahead and look at this one right here. Analyze the residual plot to determine how well the line of best fit describes the data. So let's look at this one here. And so the first thing that we notice is there's an outlier that needs to be addressed. Or in this case, how we address it, that needs to be removed. Because if we remove that outlier, we'd have a better idea of the line of best fit. Because look how this line of best fit is. Even our residuals are in a straight line except for this. Right? If this were right here instead, we would know that this was a wrong line. But even still, we have 1, 2, 3, 4 above and 1, 2, 3, 4, 5, 6, 7 below. So that outlier is really skewing our data. So we would say it's not a good fit because it's unbalanced. All right, that's how we would do that one. And so that's going to be it for tonight. There was a couple sections in here that I actually cut out because I didn't feel like it fit our overall goals. But keep these in mind, these 8 problems as you're going through this. You know, we're going to play around with these residual plots. I want you guys to get a little bit more comfortable with them before we move on. All right, thank you. Good luck on your homework.